Hey, what's up, guys? This is Chung here again. So, so let's take a look at another LeetCode problem today. Number 1314, matrix block sum. Given like m by n matrix and an integer k, return a matrix answer where each element in this answer is the sum of all elements in the matrix, where the R is within a range from I minus k to I plus k. And for same thing for the column, C is within the range of j minus k to j plus k. And R and C is a valid position in the matrix. So a few examples here, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Basically we have 7, sorry, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So what does this mean, right? So how do we get 12 here? Basically, so this condition tells us, basically we're trying to get a sum, a sum within the range of, the range is the radius of k from the current I and j. So for example, since the range is 1, right? So it means that, from 0, the range is from 1, so which means the range for the row is from 0 to 1, because the 0 minus 1 is 0 minus 1 is minus 1. It's not in the matrix here. That's why in the 0, the range, the value for the answer 0 0 is a sum of this. Okay, where that's why we have 12 here. Okay, so same thing for 2 here, right? So for number 2 here, since the row range is still up to here, but the column wise, since we have 1 and 3, that's why for number 2 here the range is like this. Okay, that's how we get 21 here, right? And then so on and so forth, right? Basically at each of the location here, we'll try to expand. We'll try to expand the range by k, actually by k to the left side and by k to the right side. If we can, if we're reaching the border, of course we'll stop there. Otherwise, that's basically the logic here. And since we're trying to get the sum of in a 2D matrix, so a common way of solving this problem is doing a pre-sum, right? Because that will give us a O1 time to calculate a part a sum within the 2D array. Otherwise, the brute force way is for each of the location I and j, we'll calculate the answers, right, by using this formula. That will be too slow. So the way to solve this problem is that first we'll create like a pre-sum, a 2D pre-sum array here. Okay, and once we have a 2D pre-sum, right, at each of the I and j, here, we'll try to use this k, right, to get us the the top left corner and then the bottom right corner. Because we can the only way we can get the pre-sum with for this range, for this rectangle, is if we know the basically the ending point and the starting point. As long as we have the ending point and starting point for the range of the current I and j, we can just use the pre-sum to calculate this range, the answer within this range. So how do we calculate that, right? So it's pretty straightforward, right? So for those who are not quite familiar with how this 2D prism works, right? Let's say we have a 1, 1, 1, 1 here, okay? And let's say we're trying to calculate the range of this one, right? Let's say we're trying to calculate the sum of this rectangle. So how can we calculate it, assuming given this 2D prism list? So the way it works is that we have if we have a prism at this location, okay, so this prism which basically it's summarize everything in this 2D or 2D matrix here, right? And then we have ending point. So let's say this is the ending point and this is starting point. Starting point is 8. It's the top left corner. If we have those two two locations, so the way we are calculating the prism for this is, so not prism, to the sum of this rectangle is that, let's say we have this uh, I and j here, okay, and then we have a II and jj here. So the way it works is we are going to calculate the prism. We're using the prism of the of this part. We're gonna subtract the prism for this part first. Also, we are going to subtract the prism of this part next. So the prism, the prism for the top part is the prism of what? The prism of the of I minus 1 and jj, right? So if we use these values, look for the prism by using this value, that's the sum of the top part. And same thing for this for the left sum here, right? For the left sum is we have a I, and then hmm, here, right? So we have a II and then j minus 1. Okay. So after subtracting those two sections, and as you guys can see, we are subtracting these sections twice, right? Which means that we have to add this section back. So after subtracting this one and this one, will be we subtract, and then we're adding this I and the minus 1 and j minus 1 back. That's how we calculate the total for this part. Okay, cool. Yeah, that's basically the idea after building this prism. And the way we're building the prism is similar like how we calculate how we calculate the sum by using the sum or prism. It's similar like we plus this, we plus I minus 1 j and we plus the j minus 1, and then we also subtract the I minus 1 and j minus 1. Similar idea here. Okay, cool. So with that we can start coding. And as you guys can see here, since we'll be using the I minus 1 j minus 1, also the I minus 1 j minus 1, and when we define this like prism array here, let's see, we have a m here and the length of the mat, and then we have n equals to length of the mat 0. Okay, so when we define the prism here, we can either define it as the same size of the m and n, or we do a m plus 1 and n plus 1. So we can either do like a n and then for in range m. So if we're defining this presum the same size of this m and n, so which means that when we do a I minus 1 and the j minus 1, we have to do a special handling. When the I and j are equal to 0, we have to handle that, I mean, separately, right? Or another way is that we can do a padding, right? Which means we're going to add like 0, 0 on the left and on the top, so that I mean later on when we use the I and I minus 1, j minus 1, we can simply ignore that because we have already handled that by adding a 0, by padding zeros, right, to this presum array here. And that's what we're going to do here, because that will make the code simpler later on. So now the first step is to build the 2D presum, right? So for I in range 1 plus m, and then for j in range 1 to n plus 1, okay? Because the 0 is our padding, that's why we have to start from 1, okay? And then like I said, the presum of I, the presum of ij equals to the mat. First, we get the current values, which is the I minus 1, j minus 1, right? Again, since we are starting from the 1 here, not 0, that's why we need to do I minus 1, j minus 1. And then we plus the presum I minus 1, j. We plus the presum of the I and j minus 1. Okay, similar like the when we use this presum, since we are adding this I minus 1, j minus 1 twice, we have to subtract that once. Okay, right? And j minus 1. Cool. Yep. Oh, sorry. Yep. And that's how we build the 2D prism. So now, since now we have the 2D prism, we can just populate our final answer here. So since the final answer is also like a 2D array here, that's why I'm going to initialize it with m and n. Okay, in range m here. So for I in range 1 to m plus 1, right? Similar like how we build the 2D prism above, right? For j in range 1 to n plus 1. So here, at each of the I and j here, we're trying to find, let's say we have a I and j. We're trying to find the the top left corner, right? We're trying to find this the coordinates, and the bottom right corner. We're trying to find those two coordinates, and but we cannot go out of the border of the 2D matrix. That's why when we find that, first let's try to find the ending point, right? I call it ending point. So for ending point I here, we're going to do a minimum of m of I plus k, right? Because the m is the border, right? It's the biggest that the I can get. That's why, if the I plus k is greater than m, then it means that, okay, it's out of the boundary. So we have to go back to that boundary with this m here, right? Same thing for the j, right? We also need to do a minimum of n of j plus k, right? So that's how we find the coordinates of the ending point. And same thing for the starting point, okay? So for the max, for the starting point, we have to do a max of 1, right? So I minus k. So and so for this one, 1 is the lowest number we can go, right? Same thing for the start of j, of a max of 1 to the I j minus k, right? So with those, like the starting coordinates and the ending coordinates, we can simply just populate the answer here. So here again, so we're using like a since we're using like a one-based I and j, so when we populate the answers, we have to do a zero-based conversion here, right? So we have a pre-sum of the what? Of the end I, so and end j, right? So that's the starting point, and then we'll subtract the pre-sum of the start, right? The start I minus one, and then the end I, sorry, the end j. Also the pre-sum, subtract the pre-sum of the end I and the start j minus one. Okay, and then in the end we simply add that double subtracted session back. Okay, start I minus one and then start j minus one. Okay, and then we just simply return the answer. Cool. All right, run the code. Okay, accepted, submit. All right, cool. So it's success. Yeah, I think that's it. It's a very straightforward, like 2D prism. A little bit of variations. The only difference that we have to use this k to find to help us find the range of the sum. And after that, it's just building this 2D prism location and how can we use that to find the sum of a specific range. Yeah, and for the time and space complexity, right? So the space complexity is m times n, right? That's a space. And the time complexity is, of course, the time is also O of m times n, right? This is pretty straightforward. Cool. Yeah, I think that's it for this problem. I'll just stop here. Okay, thank you so much for you guys to watch this video. Stay tuned. See you guys soon. Bye bye.